Welcome back to Vuln Vibes. We dissect the cybersecurity news impacting, well, basically all of us in the cloud-native space.
And today, we've got a big one.
Yeah, today we're diving headfirst into Chaotic Deputy. It's a set of critical vulnerabilities in Chaos Mesh.
And it's definitely sent some shockwaves. We're talking Kubernetes cluster takeover potential here.
Exactly. This isn't just some minor bug. It's really put a spotlight on, our internal trust models within clusters.
That's right. JFrog Security Research uncovered these, and, well, the initial assessment is pretty grim.
Grim how? We talking high CVSS scores.
Oh, yeah. Multiple CVEs and the big ones. CVSS 9.8. Critical.
9.8. Wow. Okay, for anyone listening, that score basically screams immediate and severe danger.
Yeah.
It's a direct path to potentially owning the entire cluster.
Precisely. A full takeover.
So our mission today really is to unpack Chaotic Deputy. We need to understand how it's exploited, right?
Yep. The mechanics of it.
And crucially, what this means for securing your Kubernetes environments, especially thinking about those common in-cluster attack scenarios.
And what it tells us about relying on these powerful internal tools.
Right. Okay, let's get into the nuts and bolts then. What are the specific CVEs we're looking at?
So the main ones are CVE-2025-59360, 59361, and 59361, plus there's CVE-2025-59358 involved too.
And what do they allow an attacker to do?
Well, this is the alarming part. They let an in-cluster attacker, even one starting from a totally unprivileged pod.
Unprivileged, so like minimal initial access.
Exactly. They don't need high privileges to start. From there, they can run arbitrary code on any pod in the cluster.
Any pod. Wow. And does this need some kind of weird, non-standard setup?
No,
Oh.
and that's key. This works even with Chaos Mesh's default configuration.
Okay, hold on. Default configs, that's pretty bad. Default usually implies some level of safety. Yeah.
It certainly should, but not in this case. It significantly widens the potential impact.
So how does an attacker actually pull this off? Walk us through it. From that unprivileged pod to, well, cluster compromise.
Okay, so the exploitation really hinges on getting access to the Chaos Controller Manager's GraphQL server.
The API endpoint for Chaos Mesh.
Basically, yes.
Yeah.
Once an attacker can talk to that server, they can start executing Chaos Mesh's own functions, its native fault injections.
Like the things Chaos Mesh is supposed to do. Shutting down pods, messing with networks.
Right, the intended chaos engineering actions. But here's the kicker. They can also use it to inject arbitrary OS commands directly into pods.
Ah, okay. That's the critical step, OS command injection.
Exactly. And once you can run commands, you can do things like steal highly privileged service account tokens.
And once you have those high privilege tokens,
It's pretty much game over. Cluster takeover becomes a very real possibility.
that paints a really clear picture of the kill chain. You get a foothold inside, maybe low privilege, then use this vulnerability to escalate straight to powerful credentials.
Yep. It turns a resilience tool into a weapon for compromise.
Now, does the attacker need to already be inside the network for this? Is there a prerequisite?
Yes, they do need that initial access to the cluster's network. That's the starting point.
Okay, so it's not exploitable directly from the outside internet, generally speaking.
Correct. But, and this is a big but, we know that gaining some kind of initial in-cluster access is, unfortunately, pretty common in targeted attacks. Think lateral movement.
Right. Post-exploitation becomes key. An attacker gets in through one door, then looks around for vulnerabilities like this one. It makes the internal posture critical.
Absolutely. Hardening the inside is just as vital as the perimeter.
So for listeners running Chaos Mesh, maybe in production or even testing, what are the immediate steps? Are certain platforms more vulnerable?
Well, infrastructures like Azure Chaos Studio were specifically mentioned as being affected.
Okay, good to.
The #1 recommendation, upgrade Chaos Mesh immediately. Version 2.7.3 has the fix.
Upgrade. Got it. What if someone can't upgrade right away? Is there a temporary fix?
There is a workaround. Yeah, you can redeploy the Helm chart, but critically, you need to disable the Chaos Cladle tool and the port it uses.
Ah, so disabling the command line tool access and its network listener?
Exactly. It mitigates the immediate risk by cutting off that specific attack vector used in the exploit.
That's crucial practical advice. It's almost ironic needing to contain the chaotic parts of a chaos tool.
Yeah, you could say that. What about the timeline here? How quickly did this get addressed?
It was actually quite fast. JFrog reported it on May 6th, 2025.
Okay.
The Chaos Mesh team had a fixed version, 2.7.3, out by August 21st.
That's pretty good turnaround for something this complex.
It is. And then the CVEs were publicly published on September 15th, It shows, a real sense of urgency and good collaboration when something this critical pops up.
Definitely a positive sign for the ecosystem's response, even if the vulnerability itself is scary. So let's connect this to the bigger picture. This incident, it feels like it really highlights a trend we've been seeing in cloud-native security, doesn't it? It absolutely does. It underscores the growing focus on securing internal control plane components, these tools that manage the cluster itself.
Because once an attacker is inside, even with low privileges.
Right, they start looking for ways to move laterally and escalate. And tools like Chaos Mesh, which often need significant privileges to do their job, well, they become prime targets.
So the very tools we use for resilience testing can become attack surfaces themselves.
Precisely. It's a stark reminder that you need to scrutinize the security of everything running inside your cluster, not just the applications facing the outside world.
It really makes you rethink trust boundaries, doesn't it? Especially for these powerful orchestration or, well, chaos tools. So here's maybe the final thought for everyone listening. Given vulnerabilities like chaotic deputy, especially exploitable with default settings, how are you really thinking about the inherent trust you place in components within your Kubernetes cluster? How do we proactively secure these internal, often overlooked attack surfaces against sophisticated threats that start inside the perimeter? Something to really chew on as you design and manage your cloud-native security posture.